Hey friends, welcome back to Datomix Academy. In today's lesson, we will try to build a solid foundation in SQL, which you'll use throughout your data engineer and data analytics career. In this video, first, I will talk about what a database actually is and how it helps us to organize our data. Then, I will try to explain the difference between the SQL and NoSQL, so you understand when and why each one is used. Next, we will look at how data is structured inside a database using tables. We will also break down what an RDBMS is. After that, we will try to explore the different data types in SQL, like text, numbers, dates, and more. Then, we will move into the hands-on part, how to create a table and how to insert data into it. And finally, I will show you how to use three most important SQL keywords: select, from, and where to query and filter your data. So, what exactly is a database? A database is a system that stores information in an organized and structured way so that machines, computers, and people can easily access it later. It's designed to hold large amounts of data, even millions of records, and still let you quickly search, update, and analyze that data. Databases are used everywhere in websites, mobile applications, online stores, banking systems, and pretty much every software you can think of. Without databases, it would be nearly impossible to manage and access information efficiently. So, in simple words, a database is like a smart digital storage space that keeps data safe, organized, and ready whenever you need it. Let's see the difference between the SQL and NoSQL. Those are the two types of databases that are built for different purposes. SQL databases are also called relational databases. They store data in a structured format using rows and columns, and you interact with them using a language called SQL, which stands for Structured Query Language. SQL databases are great when your data is consistent and follows a fixed structure, like customer records, orders, or financial transactions. Example of SQL databases might be PostgreSQL, MySQL, and SQLite. Now, on the other hand, we have NoSQL databases, which stands for not only SQL. NoSQL is more flexible. It's designed for situations where the data doesn't always follow a strict structure, like user profiles, product reviews, social media content, or logs. Instead of rows and columns, NoSQL might store data as documents, key value pairs, or graphs. And popular NoSQL databases might be MongoDB, Firebase, and Cassandra. The main simple difference between the SQL and NoSQL is you need to use a SQL when your data is organized and relational. And you need to use NoSQL when your data is more flexible, unstructured, or changes might happen often. Both are powerful. It just depends on the type of project you are working on. And the RDBMS stands for Relational Database Management System. And that's the software that runs the database and uses the SQL as its query language. For example, we can say PostgreSQL is an RDBMS, and we have MySQL and SQLite and Microsoft SQL Server, all are the RDBMSs. So when we say PostgreSQL, we mean an RDBMS that supports standard SQL. Let's get back to a table. A table is the basic building block in a relational database. Think of it like a Google Sheet. Each row is a record. It can represent one student, one product, or one cell, while each column is a field and a feature of that record of that row, which might be like a name, age, price, date, and more. And let's see this table. We have example table here, which is called students. And this students table, if you see, holds 3 rows, and each row represents specific student, and each column represents for each student's features like name, age, major. Yeah, that's simple, right, to understand. Now let's go one step deeper. Data types. Every column in a table must have a specific data type, and that tells SQL what kind of data to expect from that column, and how to store and search the data from that column, and how to validate those data in that column. Now, let's break down the different data types you might come across in SQL. These are really important because they tell the database how to store and understand your data. We have different groups here. The first group is numeric types. These are used for anything involving numbers. We have example like we have integer data type. That's for whole numbers like 1, 20, 25, 50, 100, 10,000 and more. Or even negative numbers like -5, -10, -100. And this data type is perfect for things like age, quantity, or student ID. Then we have decimal, float, or double data types. And these are for numbers with decimals. You would use them when precision matters, like with prices, percentages, or GPA scores. For example, 3.14, 99.99, or 0.75. Those are all examples for decimal, float, and double data types. And next, it's the text or string types. These are used for storing words like names, emails, or course names, for example. And the most popular one is varchar, and it will be used with a variable length. For example, if we have varchar 50, that means we can store up to the 50 characters. And then there is a text data type as well, which is used for longer blocks of text, like description or whole messages. It's flexible, but be careful to use it because it can be slower to search through. Third one from data type groups is date and time types. And these data types help us track when things happen. We have date, we have time, and we have timestamp. Each one represents different, like the time structure. For example, date is for only the calendar date, time is only for the clock time, and timestamp stores both date and time together. And you'd use timestamp to track mostly when a row was created, when someone is signed up, or when an order was placed. And the latest one is Boolean data types, Boolean values. And this is a simple one. And we have Boolean or bool data types, which stores just two values, like true or false. And it's great for flags like is active, is deleted, or is verified. And finally, null values. This one is important. I mean, the null means missing or unknown. It's not the same as zero, and it's not the same as an empty string. It just means the data is not there yet. You will use is null or is not null when filtering these values later. So now, if we look back at our students table, here is how we would define the data types. The ID is integer, name is varchar 50, which can only store 50 characters, age is integer, major is varchar 100. Let's give it 100 because like it might be more characters for the major. And now let's move hands-on part. Let's see how to create a table in SQL. Now you understand how a table looks and what data types are. Let me show you how we actually create a table in SQL. We use the create table command. And here's the full statement for our students example. Let's break this down. Create table students part tells SQL we are creating a new table called students. And each line inside the parentheses define a column name and its data type. This is how we define a new table manually. You only need to do this once before you start inserting or querying your data. Let's see how to insert records into the students table. We created the structure of the students table, but right now it's empty. No rows, no records, just an empty shell. To fill it with actual data, we use the insert into command. And here is the single row insert statement. If you see, there is an insert into students part, which tells SQL which table we are adding data into. And the part in parentheses, like ID, name, age, and major, tells SQL which columns we are filling. And the last part is values. It contains the actual values we want to insert and the same order. So this line adds one row, like Alice with age 20 and major in computer science. And that will raise a question, like why column order matters? Like when you use insert into, the order of the columns must match the order of the values. If you switch them by accident, like putting computer science where age should be, it will cause an error. And let's see like how to insert multiple rows at once. And instead of writing a new insert command for each row, we can add multiple rows. This adds two new students in one statement. It's cleaner, faster, and what most professionals do when loading bulk data. And there are a few tips. The first one is always match column names to values. Otherwise, you will get an error. Wrap all text or strings in single quotes. Otherwise, you will get an error. Numbers like age or ID do not need quotes. If you put quote, the system will treat it as a string. And the last one is do not forget the semicolon at the end. That tells SQL the command is complete. And there is one way as well, like inserting without listing columns. And you can technically write a statement like this, but this is only works if you provide values for all columns in the exact order they were defined in the table. Still, it's better to always list the column names, especially in real projects where the tables might change later. Perfect. We have got our table created and we have filled it with data. Now we are ready to start using select, from, and where to ask questions and pull results. Now let's dive deeper into the most important SQL command, which is select. Select is used to choose the columns you want to retrieve from a table. Basic syntax looks like this. Select column list from our table. If we adjust this syntax into our students table, it will be like select name and major from students. And this means get me the name and major columns from the students table. You can also use star to get all columns, all the list of the columns of the table. For example, select star from students. This will give us all the list of the columns from our students table. But in real projects, avoid this. Like it can slow things down, especially in large data sets. That's why, like unless you truly need every column, try to avoid using this. Let's try to understand one more thing. The result set. When we run a select query, it will give the result set the column order as the same when we provide it in the SQL statement. For example, in our next query, we can see I have name and major. It means that in the result set, I will get name and major in this order, like first name and then major, not first major and then name. And also, we can give renaming option using aliases to our result set, like in here. For example, if I want to represent my name column as a student name, I can give an alias name like this with as keyword, like select name as student name. And if I want the major as department, it means like, again, the same structure. I will need to put like select major as department. If I run this query now, I can see the result set like this, student name and department columns. Next, let's check how to filter the result set. That will be implemented using the where clause. And the basic syntax is like this. We will have like select list of the columns from our table name and where, and with our condition. For example, from the students table, if we want to retrieve all the students whose age is greater than 20, our query will be like this. Select name and age from students where age is greater than 20. In the result set, I want name and age columns. That's why I have only the name and age columns here. If I run this, you see, I got all the students whose age is greater than 20. If I want to add major as well in my result set, it will be like this. Simple, right? And one more thing, if I want to filter according to any column which consists string value, in that case, it will be like this. As we talked, string values always needs to be included in single quote. If we follow that rule, our query will be like that. Select name from students where major equals to physics. And physics is between single quotes. And if I run this statement, I'll get like this. Only one, Charlie, has physics as a major. If I want to confirm it, I can check from the whole students table, and you see, I have only physics for only Charlie.
Alright, quick recap before we wrap up. You now know what a database is, the difference between SQL and NoSQL, and what an RDBMS actually does. We looked at how tables are structured, and also we explored the main SQL data types, and wrote our first real queries using select, from, and where clauses. This is your foundation, and it's only going to get more fun from here. Next up, we will learn how to sort and limit data using order by and limit. We will also use advanced querying features using where clause. If this helped you out, do not forget to like, subscribe, and leave a comment. See you in the next class.